Hi everyone, in this lecture we are going to study about some numericals that are based on discrete sources, and it is part first video of the numericals. So here is the question that says that consider a discrete memoryless source with the alphabets S0, S1 and S2 with the probabilities, that is the probability of occurrence of symbol S0 is 1 by 4, probability of occurrence of symbol S1 is 1 by 4 and the probability of occurrence of symbol S2 is 1 by 2, and we need to find out the probability of original source as well as the second order extension entropy. So let's solve this question. So we are given that the number of symbols that are generated by the original source are 3, because here are the 3 symbols, that is S0, S1 and S2. Now these have the probabilities that is denoted as P of S0 equals to 1 by 4, P of S1 equals to 1 by 4 and P of S2 equals to 1 by 2. So this is the data that is given to us in the question. Now let's calculate the entropy. Since the entropy is denoted as h of x, which is given as summation I that ranges from 1 to n p of xi log base 2 1 over p of xi. This is the general formula for the calculation of entropy. Let's expand this formula based on our requirement for the 3 symbols, that is ps1 ps0 log base 2 1 over ps0 plus for ps1 log base 2 1 over ps1 plus ps2 log base 2 1 over ps2. On putting the values, we get the entropy as, in place of ps0 we write 1 by 4. So 1 by 4 log base 2 1 over 1 by 4 plus, in place of ps1 we write 1 by 4. So 1 by 4 log base 2 1 over 1 by 4. In place of ps2 we write 1 by 2. So 1 by 2 log base 2 1 over 1 by 2. On solving this whole expression, we get the value of h of x as 1.5 bits per symbol. So this is the value of the entropy that we calculated for the 3 alphabets, or we can say that symbols. Now here in this question we need to find out the second order extension. So here in this question the order of extension that is denoted by capital N is given as 2. So the number of symbols that are generated by the extended source, number of symbols generated by extended source would be small n to the power capital N. where a small n represents the number of symbols generated by original source and capital N is the order of extension. So simply writing the values, we classified that it generates the 3 symbols and the order of extension is 2. So the total number of symbols generated by the extended sources comes out to be 9. So let these 9 symbols are sigma naught, sigma 1, sigma 2, sigma 3, sigma 4, sigma 5 and sigma 6, sigma 7, sigma 8. So these are the 9 symbols that we lettered. So these 9 symbols also have some probability of occurrence. So that is denoted by P of sigma I, where I ranges from 0 to 8 because there are 9 symbols. Now we have to calculate the values of this probability of occurrence for these 9 symbols. So how do we calculate it? We can calculate it by one easy trick. So it is like, first of all, here we have the 3 possibilities, that is P of S0, P of S1 and P of S2. So these are the 3 probabilities that are given to us in the question. So let's rewrite it again. So P of S0, P of S1 and P of S2. Now take the one probability as a reference and multiply it with these remaining 3 probabilities step by step. So the probability of occurrence of sigma naught will be equals to the product of PS naught into PS naught. So here is PS naught into PS naught. Similarly, the probability of occurrence of sigma 1 will be equals to the product of PS naught into PS1. For the sigma 2, the probability will be PS naught into PS2. So this is how we calculated the probability of sigma naught, sigma 1 and sigma 2. So we are done with the PS naught. Let's take PS1 as a reference and we will same do the product of the multiplication for the probability of these 3 symbols, that is sigma 3, sigma 4 and sigma 5. So the probability of occurrence of sigma 3 will be PS1 into PS naught. So here is PS1 into PS naught. Similarly for sigma 4 it will be PS1 into PS1. So here is PS1 into PS1. For sigma 5 it should be PS1 into PS2. So it is PS1 into PS2. Similarly for sigma 6 we will take PS2 as a reference, then multiply it with these 3 probabilities step by step. That is for sigma 6 PS2 into PS naught, PS2 into PS naught. For sigma 7 it should be PS2 into PS1, so PS2 into PS1. For sigma 8 it should be PS2 into PS2, so here is PS2 into PS2. Now we have given the values for these 3 probability, that is PS0, PS1 and PS2. So simply writing the values we get the final probabilities at 1 by 16, 1 by 16, 1 by 8 and 1 by 16, 1 by 16, 1 by 8, 1 by 8, 1 by 8 and 1 by 4. So these are the probability of occurrence for these 9 symbols. So here are the 9 probabilities of occurrence of that 9 symbols that we discussed. Now let us have a look at the entropy of the extended source. So the entropy of extended source can be given as, since we are talking about the second order extension, that's why we can denote it as alpha to the power 2, where 2 represents the order of extension and its value is summation I ranges from 0 to 8 P of sigma I log base 2 1 over P of sigma I. So this is the general formula for the calculation of entropy. Now h of alpha to the power 2 will be equals to, similarly we can expand this formula for all these probabilities one by one. So for PS naught, writing the value 1 by 16 in place of PS naught, so 1 by 16 log base 2 1 over 1 by 16, plus for PS1 here is also 1 by 16, so 1 by 16 log base 2 1 over 1 by 16, plus for PS2 it should be 1 by 8 log base 2 1 over 1 by 8, plus for PS3 it should be 1 by 16 log base 2 1 over 1 by 16, plus for PS4 it is 1 by 16 log base 2 1 over 1 by 16, for PS5 it is 1 by 8 log base 2 1 over 1 by 8, for PS6 it is 1 by 8 log base 2 1 over 1 by 8, for PS7 it is 1 by 8 log base 2 1 over 1 by 8, and finally for sigma 8 it is 1 by 4 log base 2 1 over 1 by 4. So this is the expanded formula for entropy. Now if we simplify this whole term, then we will get to know that the value of h of alpha square will be equals to 3 bits per symbol. So you all have to simplify this whole expansion, and then we will get this result, that is 3 bit per symbol as an extended entropy. Now some of you students want to cross check your final answer, that is 3 bit per symbol is correct or not. So let's do the cross checking. So how can we do it? Since we know a relation between the original entropy and the extended source entropy, that is h of alpha to the power n is equals to n in multiplication with the original entropy, that is h of alpha. This is the relationship that we discussed in our earlier lectures. Here we know that h of alpha is equals to 1.5 bits per symbol, and also the value of n is equals to 2 because it is second order extension, that's why the value of n is 2. So if we calculate the value of h to the power alpha and in place of n we write 2, then it will be equals to, in place of n we write 2 in multiplication with h of alpha, that is 1.5 bits per symbol. So the final result of h of alpha to the power 2 comes out to be 3 bits per symbol. So this is the result that we got after cross checking by the help of this relation, and this is exactly same answer that we got here. So we can say that we evaluated the whole answer exactly same and correct. Now let us have a look at question number 2. So the output of an information source consisting of 128 symbols, and 16 out of which 128 symbols occurs with the probability of 1:32, and remaining symbols occur with the probability of 1 over 224. So these are the probability of occurrence, and it shows that total number of symbols are 128 and 16 symbols are equiprobable and occurs with the probability of 1/32, and also the remaining symbols are also equiprobable, which occurs with the probability of 1/24. 224. Since the source emits 1000 symbols per second, so this is the rate which is given to us, and we have to assume that the symbols are chosen independently, and what we need to calculate is we need to just determine the information rate, that is denoted by capital R. So let's solve this question. So here first of all we will write the data that is given to us. So here the total number of symbols is equals to 128. So 128 symbols are there. Also the probability of 16 equiprobable symbols are probability of 16 equiprobable symbols are 1 by 32. So this is 1 by 32, and also the probability of remaining symbols, that is total is 128 and 16 out of which are occurs with the probability of 1 by 32. So remaining symbols are 112, which are also equiprobable. And here is the probability given to us, that is 1 by 224. Now since we need to calculate the information rate, that is R will be given as small r into h of x, and here the value of small r is given, that is small r is equals to 1000 symbols per second. So this is the value that is given to us. So to calculate the information rate R, we have the value of R, but we don't have the value of this entropy. So firstly we will calculate the value of this entropy, that is h of x. Now let's calculate the value of h of x. Since we know that the formula for the calculation of h of x is given as summation I equals to 1 to 128 p of xi log base 2 1 over p of xi. So here are 128 symbol, that's why we have written the value of n equals to 128. Now we can expand the value of this h of x into two terms, that is first for the 16 equiprobable symbols that ranges from 1 to 16, having the probability pxi log base 2 1 over pxi, plus the second entropy calculation will be for the remaining 112 equiprobable symbols. So I ranges from 1 to 112 pxi log base 2 1 over pxi. Since we have the value of the probability for these 16 equiprobable symbols, so its value is summation I equals to 1 to 16 1 over 32 log base 2 1 over 1 by 32. Similarly, summation I equals to 1 to 112, its probability is 1 over 224 log base 2 1 over 1 by 224. Now h of x value will become 16 in multiplication with this whole term, that is 1 by 32 log base 2 1 over 1 by 32. Similarly, for this summation I equals to 1 to 12, its value will be 112, and it will get multiplied with this whole term, that is 1 by 224 log base 2 1 over 1 by 224. Now this will get cut with this 2 times, and it will also get cut with this 2 times. So the final value for h of x will be 1 by 2, and log base 2 1 over 1 by 32 will become 5 only, plus here is 1 by 2, and log base 2 1 over 1 by 224 will become 7.808. So the value of h of x is equals to 6.404 bits per symbol. So this is the final value of entropy that we want to calculate the information rate. Now finally let's calculate the value of information rate. Since r equals to small r into h of x, and we know the value of small r is equals to 1000 symbol per second. So simply substituting the value of small r here, we get 1000, and for this expression we get the value of h of x as 6.404. So the final value of r is equals to 6404 bits per second. So this is the value of information rate that we want to calculate in this question. If you like my content, then do subscribe my channel and please hit the like button. Thank you.